Hello and thanks for watching Best Maths Tutors. What we're going to be looking at is SOHCAHTOA in right-angled triangles, and so this is basically a grade 5 topic, so it's somewhere between the foundation tier and the higher tier paper. So there's two things we can be looking at, and one is finding angles in a right-angled triangle, and the other thing is finding lengths in right-angled triangles. So to move on then, to actually look at what does SOHCAHTOA mean. So SOHCAHTOA is actually an abbreviation, and it stands for sine is equal to, so sine of an angle, so imagine we've got an angle there, so I'll call that x. And we could say sine of the angle x is equal to opposite over hypotenuse, and the c there stands for cosine, and that's abbreviated as cos. And so we could say cos of our angle x is equal to, and A stands for adjacent. I'll explain what adjacent and hypotenuse and opposite stand for in a minute. So we've got the cos of the angle is equal to the adjacent over the hypotenuse, and then we've also got T stands for tangent, so that's abbreviated to tan x, and tan of the angle is the opposite over the adjacent. So we need to know what all these things mean: opposite, hypotenuse, and adjacent. So these are where we are in relation to the angle. So if we're in a right angle triangle, that's a 90 degrees like that. And we could then, if we had an angle here, we could talk about where the sides are in relation to that. So we're saying the one actually opposite it, so this is opposite, is this one, and this is our opposite side. And what I've done is I've abbreviated that by saying op. And adjacent is just another word for next to, so that would be this one is our adjacent. Let me just give myself a bit more space about that. Adjacent. And the one opposite the right angle, and this is always our longest side, is called the hypotenuse. And there we go. So that's how we would label this. Now, it always depends where the angle is that we're looking at as to which one is the opposite and the adjacent. So if I drew a very similar triangle to this, so let me draw a triangle here, and there we go. So if this was our angle now, x, then the hypotenuse would actually be in the same place, but the adjacent now is the one next to the x, and that would be this one. So it's always important to know where the adjacent and the opposite are, and the opposite now is the one that's opposite. So this is this one, that's the opposite. So what we're going to do is we're going to look at how we can use these then. And so first of all, we're going to look at one example from each of sine, cosine and tangent. And we need to, when we're looking at a question, we need to be able to identify which function we need to use. So if we're looking for the size of angle BAC, what does BAC mean? Well, the middle letter is where the angle is that we're looking for. So I'm actually going to call that X there. So BAC is where the middle letter is, and so that's where angle X is. And so we need to decide, are we going to use sine, cosine, or tangent in this one? And the way I would do this is I would look for our SOHCAHTOA, and it's actually quite useful to write it with the middle letter raised, and I'll explain what that means in a second. So SOHCAH and TOA. I just realised I'm writing underneath the calculator there. So TOA. And So to do that, we're going to say, well, which side is the length that we know here? And that's the one that's opposite to the x. And we've also got the hypotenuse, which is here. I've also got a cat that's just joined me. So anyway, we've got the hypotenuse and the opposite. So that tells me that I'm going to choose this one, because that includes the opposite and the sine, the opposite and the hypotenuse. And so if I want to find what x is, I can say, well, sine x is equal to the opposite, and you can see why I've written the O a little bit raised there, because that tells me that's the top of the fraction, the opposite over the hypotenuse. And then what we can do is we can replace the opposite by 12 and the hypotenuse by 13. So move the page over slightly just so you can see what I've done there. So there we go. So it's 12 over 13. And what we then need to do is, if we know that sine of the angle we're looking for is given by this fraction, well, we actually need to use on our calculator sine minus 1, which is called our inverse sine. So we're going to go 12 over 13. And so I'm going to go to my calculator now. And what I'm going to do is I'm going to type in, I'm going to go shift to get the sine out. And an important thing here, you can see there we've got R for radians. Now we don't want that. We need to be, this is a good thing to actually recognise, we need to make sure we're in degrees mode for GCSE. And so what we need to do is use the angle unit there. So that's, there we go. And we need to make sure we're in degrees, which is by pressing 1. So we're going to degrees mode now, which is represented by the little d there. So what we're going to do is we're going to go shift sine, and that gives me the sine minus 1, because that's written in orange there. You may have a different calculator to the one I've got, but the principles should be pretty similar. And then I'm going to use my fraction button. I'm going to go 12, oops, I should have said 12, and just navigate to the bottom of the fraction, over 13, and then close the bracket, and that gives me my angle. So 67.38, and I might round that up to 67.4 degrees. So there we go, that's the first one done, 67.4 degrees. Okay, so I've got another question now. So this one is going to use a different function. So what I would recommend doing is looking at where the angle is, and then let's label the sides of the triangle. So we'll say this one is opposite to it, so that's the opposite. This one is the adjacent, and the one that's always opposite the right angle is a hypotenuse. So what we've got is the adjacent and the hypotenuse. And so if we again just write down SOHCAHTOA. Oh, TOA. I was going to write that. I'll just write that up there. TOA. We can see that what we've got is the adjacent and the hypotenuse, so we have to pick this one, which is the cos. So we can say cos of the angle x is equal to the adjacent over the hypotenuse. And all we're going to do is just then plug in the numbers that we've got for the hypotenuse and the adjacent. So we're going to say that cos x is equal to 16 over 24. There we go. And again, just getting the calculator up. So I'm just going to plug that in. So if cos x I need to say actually if cos x is equal to 16 over 24, then it's x that we're interested in. So x is actually equal to the inverse cos, which is when you have cos to the minus 1, and that's 16 over 24. So I'm just pulling that back up again. And so we're just going to go shift cos this time and use the fraction button. 16 over 24, and then just navigate out of there. And then they want to put a comment and ask me to clarify anything that we're covering. Please feel free to. So if you ask me a question, just if anything I've not explained properly, just let me know. So I'm going to look at another one now. So I'm trying to cover all the possibilities. So this time, again, labelling the sides we've got. The long side opposite the right angle is the hypotenuse. The one opposite the x that we're looking for is the opposite. And the one that is next to x is the adjacent. So we can say, again, I'm just going to write this out. I think it's always a good idea to write this out before you start a question. So SOHCAHTOA. And we can see that this time we've got the information that we do have is we've got the opposite and the adjacent. We don't know what the hypotenuse is in this case. So that's going to be tangent that we're going to use. So we can say this time tan of x is equal to the opposite over the adjacent. Making sure I'm not going off the page underneath the calculator there. And if I plug in the numbers, what I've got is the opposite is 3, the adjacent is 6. So that's what tan x is, and we're interested in finding x. So that is equal to tan minus 1, so the inverse tan of 3 over 6. So I'm just going to plug those numbers again into my calculator. So if I do that, what I will get, so I'll just clear what I've got already. So shift tan, and so I'll just put the fraction button in, and it's going to be 3 over 6, and there we go. So tan minus 1, 3 over 6, 26.56, and if I round that up to say 1 decimal place, there we go, and that one was 69.5 degrees. So x was 69.5 degrees. Okay, so this time, so this is the one I actually meant to do. This one, we are now looking for a length. And we can see that because we've actually, the length there is labelled as x, and we're given the angle. So in order to use trigonometry to find a length, we need to know the angle, which we do in this case. So what we can do is we're still going to look at which sides we've got. So the 20 is the opposite. So there we go, opposite. And the x is the hypotenuse because it's opposite where the right angle is. Also, the hypotenuse is the longest side. So we're going to write out SOHCAHTOA again, whether or not we're looking for a length or an angle. So SOHCAHTOA. And this time we've got the opposite and the hypotenuse. So that means we're going to choose sine. So I can set that up and I can say, well, sine, and this time it's of the angle. So it's 35. So we're not going to write x there anymore. We're actually going to write sine 35 and that's going to be equal to the opposite. So the opposite we can see is 20, and the one that we're looking for is the hypotenuse, which is the x. So we can try and rearrange this to make x the subject. And so if I multiply both sides by x, so I'm going to times by x there, I'm going to times by x there, what I will get is I will get x times sine 35, and that's going to be equal to 20. And we're nearly there with this rearrangement, but I can just divide through by sine 35 now on both sides. And if I do that, I'll get the, so sine 35, sine 35. So remembering with equations, I've got to do the same thing to both sides. So that's going to disappear, and I'm going to end up with x equals 20. Well, let me just move the board a little to the right there, to the left, so we can see the working that I've just done. So yeah, we end up with x is 20 over sine 35, and that's again just a case of putting that into the calculator. So I'm just going to clear that, and it's just a fraction button, and it's 20, and then in the bottom of the fraction, what I need to do is, I'm not using sine minus 1 now. That's an important thing to note. We're actually putting in just the sine, so we're not pressing the shift button this time. Okay, so we're just pressing sine, and it's 35, close the brackets, and just pressing the equals there will give us the length. So the length of the hypotenuse in this case is 34.868, etc. And say I was round that up to 1 decimal place, then I would say that was 34. And the units for this one, so it's important to look at the units in the question, are centimetres. So there we go. So did I copy any more? I think what I've got next is, so we can actually do this now with more difficult problems. So it's not always obvious that we've got a right angled triangle in all this, but I thought I'd look at what might be an exam problem as well, a slightly more difficult one. So what we've got to do is we've got to work out the size of angle BAD and give the answer to 1 decimal place, as it says there. So BAD is looking for this angle here. So where the middle letter is where the angle is. So it's there, and so that's what we're looking for. But we need to try, if we're going to do it into trigonometry, we need to try and create a right angled triangle. Now I can do that by drawing a line across here, and if I do that and I make that 90, so it's going straight across, creating a rectangle there, then that would also be a rectangle there. So since we know this angle here is 90, if we could find this one as well, so I'm going to call this x, then we can see that BAD would be given by this 90-degree angle plus the x. So I'm just going to write that down. BAD is going to equal 90 plus x. So we're going to look at this triangle that we've created, and I think I'll just draw that on its own. So if I do that, there we go. Now we know this length here is 15 meters because it's going to be the same as this one. But we need to know, oh, this is x, but we do need to know what this one is. So how can we find out what length that is? Because we need to know 2 things in this triangle before we can work out what the angle is. Well, if we go back up go back onto the original diagram, we can see that if this is 4 meters, that means this would be 4 meters, which, since the whole length is 6, then this part of it must be 2, because 4 plus the 2 has got to add up to the 6. So we know that that's going to be 2 meters. So now we've created a triangle where we can find what x is. And again, I'm going to write down the SOHCAHTOA bit. So SOHCAHTOA, and what we can see is the ones that we've got, if I label them, we've got the opposite and we've got the adjacent. So that means that we're going to pick the tan. So we're always picking the one that contains the information we've got, or information we're looking for. So we can see that because we've got the opposite and adjacent, that's only contained in the tan. So what I'm going to do then is just set up my equation. So I'm going to say that tan, by just plug in the numbers, well, we can see that the opposite is 2 and the adjacent is 15. So let me just get the calculator up to work that out. So, so what I need to do, so that's tan x, and we just move the board up a little, and we need x, so that's going to be the inverse tan, which is shown by the tan minus 1 of, there we go, of the fraction that we found there. So to get that, I've got to go shift and then tan. So that gives me, in orange on my calculator, is written tan minus 1. Okay, as I say, you may have a different model of calculator, but I'm sure you'll have to press shift to get shift, or second function is another thing, to get the tan minus 1. So I'm going to just press the fraction button there. So 2 over 15, close the bracket, and there we go. We've got a small angle, that we'll call that 7.6 if we do that to 1 decimal place. Okay, 7.6. In fact, let me just work that. I'm going to work that to slightly more decimal places. So we'll call that 7.59. Just write it to 2 decimal places at the moment. Now, my reason for doing that is because the final answer to this question was supposed to be to 1 decimal place. Now, that's x, but if I go back up, we can see that, in fact, BAD, what we're looking for, was 90 plus whatever x is. So BAD equals 90 plus x, and x is the 7.59, and so that would give me 97.59, and then if I round that up to 1 decimal place, that means I'm cutting it off there. And of course, the 9 is 5 or more, that's going to become 97.6. And that's it, we've done it. So I hope that's been helpful, and if it has, we'd love it if you'd subscribe to our channel and do more live streams, hopefully